All right, good morning. It's just after 8 o'clock, so we'll go ahead and get started. Probably keep this one fairly short, but we'll get through all the material. All right, so the material for this week is all about arrays and lists. In Python, an array and a list are actually the same thing. I will kind of use those words interchangeably. Sometimes I'll say array, sometimes I will say list. But in Python, both of those things are the exact same thing. Okay, so what is an array? Well, first of all, let's look at what an array looks like. An array looks something like this. Say A is equal to, and then we have these brackets. And then inside of here, we have what we call the elements of the array. This is what an array looks like. You have the name of the array, the variable name. I'm just calling it A. But just like with any other variable, you can name it whatever you want to name it. That's perfectly fine as the name of an array. But we'll just keep it as A. And then you have, let's delete this out here for a second. You have these brackets, an opening bracket and a closing bracket. And what this is telling us is that in Python, this is an array. This is a list. Inside of here, we'll have individual elements of the list. So what is the list? The list is nothing more than a collection of individual values. What I mean by that is each of these is an individual value, right? 1 is a value, 4 is a value, 7 is, 1 is, and 23 is, right? But if we aggregate those all together into one variable, we can put them inside this list, and we're going to call that list A. It's just a collection of more than one value. And it doesn't have to be numbers. It can be strings if we want. Right? Yeah, it can be something like that, and that's fine. So now we have a list of strings, and this has 3 strings in it, right? They don't even have to be the same type, meaning, the first example I had number. This is string. Well, we can actually mix them. We can have integers, we can have floats, we can have strings, and that's about all that we do so far in basic Python, and that's fine. That is just these 3 values in one list. Okay, so it's a sequence of individual values is what a list is. Okay, so first let's talk about, well, how do we access those individual values? Let's do some simple examples. Let's just say I have the numbers 1, 2, 3, 4, 5 in there, right? Those are the values in my list. Well, if we do a print A, this is just going to print out all the values, right? It just prints out the list because A is all of the values, right? Well, what if we want to just access one single individual value? Well, arrays are very, very similar to strings. Like underneath a string is an array. But with this kind of array, this kind of a list, we could do some things that we can't do with the string. And we'll see that. So if we want to access an individual element in this array, we use the brackets like that, right? This is saying this list A, I want to access the index 0. And we've talked about indexes before where indexes start counting at 0, meaning this is the 0 index, this is the 1 index, this is 2, 3, and 4. So if we access A at the 0 index, it's really getting us this very first thing in here. So this should give us a 1. We run it, print it, there it is. It gives us 1. If we want to access the third one, which one is that? It's not here, right? Because we start counting at 0. So this is 0, 1, 2, 3. So this should give us a printout of 4. And it does. Let's mix these numbers up a little bit. Let's just make up some numbers. So now if we do print A of 3, what's it going to be? Actually, let's do 1. If we print A at index 1, what are we going to get? Should get 3456. We run it, and indeed we do. We get the 3456. So that's how we can access individual elements. Again, it's index 0, index 1, index 2, index 3, and index 4. And that's how you would access them. Now, unlike a string, we can actually modify these individual values. Remember when we talked about a string being immutable, meaning once you create a string, you cannot change individual characters of that string. Well, a list is actually different. We can change individual characters, or in this case, individual numbers. So let's make let's print out A at index 1. Now let's give A at index 1 a new value. We'll call it 45, whatever. And then let's print A of 1 again. When we did this with strings and we tried to change an individual character of a string, Python will give us an error. That's not the case anymore. We can change individual values in this list, in this array. So there's the array. We're going to print out A at index 1, which is this 3456. We're going to change the value to 45, and then we're going to print it out again just to make sure it's 45. Save and run it. There we go. It starts off at 3456, and now it's changed to 45. Let's just print the whole array instead of that specific one. We do this, we run it. You can see that at index 1, it starts out at 3456, and now index 1, it is 45. So we are able to change individual elements in that array. Likewise, we could have put 3 here. What's the third index? 0, 1, 2, 3. That's 98. So it should change the 98 to a 54. And there it does. 98 changes to the 54. So that's how we can access individual elements. And then we can change individual elements. Let's say we just want to increase it by 1. A of 3 plus 1, like that. Let's change it to index 2. What's this going to do? It's going to look at index 2, 0, 1, 2. It's going to see that. It's going to add 1 onto that and save it back in there. So that 1 should change into a 2. And there it does. We have the 1 that changes to a 2 because we did this mathematical operation on it and saved it back into that same spot in the array. Okay, so about traversing an array. Traversing an array is really not that much different than what we did with strings. So it's a for loop. You say for value in the array, and then we will just print the value, right? These for loops should not be anything new to you. What it does, it looks at this right here. This is this list. It's going to say for the value in this list, print the value. So the first time in the loop, value is 34. The next time in the loop, value is 3456. The next time in the loop, value is 1, and so on and so forth. What this will do, it'll just basically print all the array one at a time. So let's start by printing the entire array, and then we'll do the loop to print each value one at a time. Save it and let's run it. And there you go. There's the whole array, which is this right here. Excuse me, is that print statement. Then we do the loop, printing out each value one at a time. So that's one way we can traverse over the array. And of course, we could do something useful with this. We could do value times value. That's computing the square of it, right? Let's print answer. What's this going to do? It's going to take each value, multiply it out, get an answer, and print out the answer. Let's save it and run it. There you go. That's just that mathematical operation done on each of those values. Have a question? So once you change it, you can never go back and access the old list? No, you always have access to the original list. Well, let's put that down a little bit. So if you have this, if you want to change a single value, we can do that. Let's get rid of this stuff for a second. Save it and run it. So we still have the original list. The list is still A, but when we said A of 2 is now 67, what we have lost is this one value, right? Because index 2 is right here, right? This is index 2. So here we're saying index 2 is now 67. So we have lost the 1. We have lost that, but we still have the array. The array is A, and we still have A. But we have lost this one value because we said something else is saved in that array at index 2. So whenever you do this right here, you do lose the original value of what was there before. All right, let's go back and talk about loops for a second. And so that's one way to do the loop. And like we were just saying, you can modify individual values, right? So let's do this again. Let's show this example. Let's say we wanted to compute the square of each number, right? So that's our array. We're just going to print out the array. We're going to loop over all the values in the array. We're going to compute the square of each value, and then we're going to print it out. And then we're going to print out the original array again. So the question is, when we do this print A, what numbers are going to be given to us, right? Is this going to be the square of all of the numbers, or is it going to be the original numbers? The answer is, it's still going to be the original numbers. See, here's the original array. There's where we computed the square of each number. And then down here, we're going to print out the array again, and it's still the original numbers. Why is that? Why isn't it those numbers squared? Well, the answer is because we never changed the values in the original array. We did do a loop over all the values, and we just said answer is equal to its square. But if we want to change the numbers in here, we have to store it back in there, meaning we have to say A at some index is equal to answer. That's pseudocode right there. Some index isn't actually valid Python code. So if we wanted to change all these to be the square, we have to store it back in that array somehow. And if we want to do that, then this isn't a good way to do the loop. If you want to change the values in the original array, you need to do the loop like this. And we've discussed this loop before. And we won't print it again. Let's delete that out. I said, this isn't the first time you should have seen this kind of loop. I've explained this loop before. The length of A, that gets how many elements are in here. So the length of A right now is 5 because there's 5 things in here. If I put another one, now the length of A is 6. So this helps compute how many elements are in the array without you having to manually count them up. Now this range, this I in range, it lets you count how many ever numbers that is. So for example, if we did range of 3, then this loop would be I0, I1, and I2. it goes up to 1 minus whatever that range number is. So if range was 7, it would go I would be 0, I would be 1, 2, 3, 4, 5, and 6. So whenever I do this I in range, the length of A, if the length of A is 6, then in our loop, I will be 0, 1, 2, 3, 4, and 5. And how does that help us? Well, what is the value at A of I? What is that right there? So I told you I will be 0, 1, 2, 3, 4, 5, right? So the first time in the loop, this will be A at index 0, which is our first number. The next time in the loop, I is 1. So this will be I at index 1 is this number. So this is still iterating over the entire list, one item at a time, and just printing the value. Let's do it. And there you go. You get the original list, which is that print. Then we do our loop, printing each value one at a time. And you see all those values are what's in the array one at a time. And then we just print the original array again. So now that we have A of I, let's compute the square again. And let's save it back in the original array. Let's take out that print. So now what are we going to get here when we do this second print? Now we do have those numbers squared. And why is that? Again, this is our array. We just print out the array, which is this first line. We're going to do this loop. We're going to get the value at that index. We're going to do this math operation. Here we're just squaring the number. And then we're going to say the array at index I is equal to that answer. So we are modifying the element in that array. And then we are just printing the array. So that's how we changed the values that are in there. This is actually part of what you have to do for your assignment. In your assignment, you have to compute some temperatures from Celsius to Fahrenheit. Well, whenever you have your list of Celsius temperatures, you need to loop over that list. You need to do some kind of mathematical operation on the value, and then you have to save it back in the list. So hint, 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 compute or convert Celsius to Fahrenheit. Okay. 1 second. Okay. So what else can we do with lists? We can do some kind of operators on them. Let's say I have this for A. I'll just put 3 numbers in there. So we have another list B, and it has this. Oops. So we have list A, list B. Let's print the A. Let's print the B. Let's say we'll have C will be equal to A plus B. And what do we think this does? Some of these operators are pretty common sense. They're not hard to figure out. So if we have list A plus list B, it just gives us a new list with all of those elements in there. Seems easy enough. We run it. There we go. There's A, there's B, and there's the list of A plus B. It just takes A and concatenates B onto the end of it. So as you can see, A is 34, 34, 56, 1. That's the first 3 items. And the next 3 items are what's contained in B. That's easy enough for A plus. It just concatenates the 2 lists onto each other. Right? There's really only one other operator for lists. Let's say, and it's the multiply, and it just takes a list and a number. Let's say we make C is equal to A times 2. What do we think that's going to do? Is it going to multiply each element by 2? The answer is actually no. It's not what it does. What it does is it will duplicate that how many ever times. So when we say A times 2, it will take this list and duplicate it this many times. So we put A times 2. We can see that this is A, and now this is C. It's A, but it's twice, right? Likewise, we could put 4 here, and it wouldn't duplicate it 4 times. There we go. There's A, excuse me. There's A, and there's A 1 time, A 2 times, A 3 times, and A 4 times. So that's what the multiplication does. And that's really the only 2 operators. You may ask, well, what about subtract and divide? And there actually is not a subtract and divide for list. Really only the plus and the multiply are what exists for the list. All right. Talk about array slices. You've done string slices before. Oops. Done string slices before. Say we have this list, and a string slice means we can get a subsection of the list. Meaning, if this is A, let's say we only want the middle 2 elements, which is 22 and 33. This is how we do it. We have B is going to equal to the list A. We have the brackets. We have a colon in between. And here we have 2 blank spots I've left in here. This first blank spot is the index you want to start at. So if I put 1 and 3 here, what am I going to get? Well, this is saying I want a subsection of this list. I want to start at index 1. Index 1 is right here. I want to go up to index 3, but it's index 3 minus 1. It's just the way Python works. So what is index 3? This is index 0, 1, 2, 3 minus 1. So it should give us just these 2 numbers right here. And there we go. B is just those 2 middle numbers. If we just wanted the first one, we could start at 0 and go to 1. That would start at index 0 and go to index 1 minus 1. So it would start at 0 and stop at 0. And there's, you see, we only get the 11. Likewise, we can put 3 and 4 here. And we're going to get just the last one. So that's what a string slice is. It's just a subsection of an array. And you have to specify where you want to stop at, or excuse me, where you want to start, where you want to stop. And remember that this is always, you will stop at 1 minus this number. All right, got a couple of array methods. So let's put B back on here. All right, so there we got A and B. Remember, we did have C is equal to A plus B, right? So print A, print B, print C. And remember what that does? That just takes A and B and adds them together, or concatenates them. See A, excuse me, A, B, and C, right? Well, let's say we want to add it back onto the original. We want to append B to A. Well, extend actually. Let's say we want to add one individual element to A. We can use A dot append, and we put the value we want to append. Let's put a 99 on there. So now when we print A, we run it. This is the original A. That's the B and the C. And here's the A after we did A dot append. We appended 99 onto the end of that array. So that's how you can add additional elements to it with append. Now, append is for single elements. If we have an entire array we want to add on there, we use extend. And let's just say I want to extend B. What this is doing is taking A, it is extending it by B, meaning B is this list, and it's just going to add it on to A. Run it. There we go. There's A, there's B, there's C, and there's A dot extend B. You'll notice these last two are the same, and that's because A plus B, A equals A plus B. These two things are actually the same. A is equal to A plus B is the same thing as A dot extend B. Those are the same thing, just two different ways to do it. All right. Let's look at these. Print it out again. There we go. There's A, there's B, there's C. We can sort C. These are mostly in a sorted order. But if we want to sort something, we can just do the list dot sort. Let's print C. Let's save and run it. And there you go. Here was the C before the sort, and here's the C after the sort. It puts them in sorted order. It's pretty easy. All right. Those are the main ones. There's a couple more. All right. So we have this list. Let's just go back down to just A. So we have this list A. There we go. That's just A. Let's say we want to remove items from it. Well, how do we do that? We do array A dot pop. And inside of here, we can either put an index or not put an index. If we don't put an index and we do pop, it will remove the last item. So you see here was A, we did A dot pop, and you can see we have removed the last item. You can do it multiple times. That, will remove the last two items. There you go. You see the last two items have been removed. So if you just put pop with no parameters, it removes the last one. You can put the index you want to remove. So if let's say I put 4 there, pop 4. What index is 4? There's 0, 1, 2, 3, 4. That is index 4. So this will remove that value 55. And you can see the 55 has been removed. You can put multiple of these together. So this will pop 4, then pop 1. So first it will remove this because that's the 4 index. Then it will remove the 22 because that's the 1 index. And there you can see the 22 and the 55 have been removed. Where you have to be careful is this. Is this going to give us the same answer? It's actually not. And why not? Because whenever we do the A pop 1, at that point, A will be this. Right? After we do A pop 1, it removes the 1 index, which is this. Right? Now we're going to do A pop 4. And what does that give us? We're going to remove the 4 index, not the 4 from the original one, but the 4 from this one, because we've already removed something. So this is what our array is right now, and we're going to pop the index 4 right now. The index 4 right now is 0, 1, 2, 3, 4. So this will remove the 66. Save it and run it. And you can see we actually get a different answer than what we got last time. So when you're doing these pops, you have to be careful about the order that you do them in. All right. So when you do the pop, yeah, I forgot about that. It'll actually give you the value as well. So put val is equal to that, and print A and print val. So what is at index 1? It's the 22. So this will actually give us that 22 value. You can see it right there. It will return to you the value that was removed. So likewise, if we do pop 3, I think that should be the 44. We run it, and there you go. There's our original print A. Here's the print A with it popped out, and that's the value that was actually popped out, the 44. Okay. If you don't care about what the value was, you can just do a delete and which one you want to delete, like that. So this is the same thing. It's going to look at A of index 3, which is this right here, and it's just going to delete it out, and then we'll print out A. This is just like pop, except it does not give you the value. So if you do val is equal to that, try to print out the val, what's going to happen? It's going to be an error because delete A does not give you a value. It just removes it. So there you go. It does remove it, but it doesn't give you the value back. Last one we'll look at is, the delete takes the index, the pop takes the index. There's one more called remove. And here you put the value you want to remove. So I could put 11. We use remove when we have the value we want to remove. We run this. You see the 11 is now gone. So that's different. A dot pop is by index. A dot remove is by value. Oops. That's how you have to remember it. Pop removes at a specific index, and value looks through all of these and finds the matching value and takes that out. So we do remove 55. It will find the 55 and remove it from your list. And there you go. You see the 55 is now gone. Right. Just one more little area to cover. Talk about arrays and built-in functions. Remember, we've been talking about some built-in functions for a while now. What are some of the built-in functions we can do? Well, we've already seen one of them. We can do the length of A. What's the length of A? Right now it's telling us it's 6. And that's right, because there's 6 things in the list. Let's add some more. Now, if we save it and run it, there are now 11 things in the list. So that's what the length of the array does, is it tells you how many things are in that list. We can do max. Max will give us the highest value in the list. Run that. It tells us the highest value is 32546, and that's right. If we look at all of our lists, that is indeed the biggest value. We can do min. It gives us the smallest value. We run it. It tells us 5 is the smallest value, and that's right. Just looking at the list, 5 is the smallest value. We can do the sum of the list, and that is all of the numbers added together. That's the sum of everything in there. where this can really help you, and it could have helped you on your one of your previous assignments. Let's say we want to get the average of all of these. What's the quickest way to get the average of all of these? Well, I could make a loop for each value in A. Let's keep the sum is equal to 0. The count is equal to 0. So the sum will equal sum plus the value. Count plus equals 1. And U plus equals. So to get the average would be the sum divided by the count. Now print the average, right? That's one way we can get average. These like 7 or 8 lines of code, right? If we run that, it tells us that's the average. Okay. What's a faster way to do it? Average is equal to the sum of A divided by the length of A. Same thing. Save it and run it. Oh, int sum length of A. What did I do wrong? Int object is not callable. Oh, it's not the sum of A. Oh, that's where I messed up. What the error is, so sum is a built-in function, right? But here I'm saying, I'm changing what it is. I'm saying sum is a number. And so I'm trying to use this built-in function, but I've renamed, or not renamed it. I've changed sum to be an actual number instead of a function. So that was bad of me. Let's do that. There we go. That's better. All right, so there you go. We get the same answer in significantly less code, right? This is one line to compute the average, and this is 1, 2, 3, 4, 5, 6 lines to compute the average, right? And you don't have to worry about loops or anything like that. It's just much shorter, one liner right there. So that's only a few of the built-in functions. And we only really covered a few of the array methods themselves, but at least it gives you a good starting idea. And it's the extent of what you'll need for this course. If you want to read about more functions and stuff like that for arrays, then use your favorite search engine and look at the Python documentation. The documentation is the best way to figure out what functions are available. Okay. That's all in the material. Let's talk about the assignment for a minute. So for your assignment, you have to have the user input, I think, 10 days of temperature in Celsius, right? And then you have to convert those temperatures to Fahrenheit. And then you have to figure out how many days were hot, cold, or warm, right? So I'm not going to go over how to input. Well, all right, probably do more than I should. Let's say we have an array. Let's say we want to convert kilometers to miles. Okay. So we're going to ask the user how far they drove for I in range 23. We're going to ask them for 3 days of driving records. Say B is equal to an integer input. How far did you drive on day I as my prompt? Okay. Now we need to keep a list of how far they drove, but we already have a list called A. We do A dot append B. Take it one step at a time. Let's print A. Let's run it. How far did you drive on day 0? I drove 1, then I drove 2, then I drove 3. And you can see our array now has how far they drove, right? Do some different numbers, 65, 45, 22. just to show you. So this array A now has, it is an array, it's a list of how far they drove each day. Let's convert that to kilometers, or kilometers to miles, miles to kilometers, whichever. So for I in range the length of A, we've already seen that loop. We say A at index I is equal to A at index I times 2.3 or something like that. This is, this is converting miles to kilometers. It's something like that, 2.3. It's like 2.3 kilometers per mile, something I don't remember. Let's just say that's it. Let's add some comments in here. Array of distances, loop asking user how far they drove. Say debug print, and what I mean by debug is we're just going to print out the value so we can see if it's what we expected. Now loop converting miles to kilometers. I don't even know if that's the right formula. I'm not that worried about it for the example. Let's do another debug print. Print A. And now we're going to see what was long distance and what was short distances. Determine long or short distance. So num long starts out at 0. Num short starts out at 0. Let's loop over the array. Let's do it this way now. For V in A, for each value in A, if the value is greater than, let's say 50, then say long trip. Else, it's a short trip. And then we'll just print out the number of long trips and the number of short trips. All right, let's save it and run it. Where's my mouse? There it is. How far did you drive? You drove 20 or 2, 33, 2, 11, and 56, whatever. Okay, so let's look at our output. So first we're going to print out what they typed in. This is what they typed in, 211.56. Then we did this loop converting miles to kilometers, and we print it out again. So this is each of those converted to kilometers, right? And then we're doing this loop down here, looping over this array. If that value is bigger than 50, it's a long trip. Else, it's a short trip. And then we're going to print out the long and the short. It told us we had 1 long trip and 2 short trips. Is that right? Well, our cutoff was 50. So we have 1, 2 less than 50. So 2 short trips, and that's right. And 1 long trip, and that's right. Okay, let's say instead of 3 days, we want to ask them for 6 days. Save it and run it. We drove 1, 10, 20, 30, 40. Oh, 50. There we go. So does this work right? So here's what we typed in. 1, 0, 20, 30, 40, 50. 1, 0, 20, 30, 40, 50. This is each of those numbers converted to kilometers, using our little loop right here. Now it's telling us we have 3 long and 3 short. Is that right? Well, if we just look at it, we have these that are over 50, so that's 3 long, and 3 less than 50, 3 short, and that's right. So this is fairly close to what you have to do for your temperature. Just instead of kilometers, you're doing temperature, Celsius and Fahrenheit. And here I'm just doing long and short, but for your assignment, you have to do hot, warm, and cold. You have to check 3 things instead of just 2. All right. That wraps up the material for this week. If you have any questions, go ahead and let me know. All right, the question was, for our assignment and final project, are you concerned with us truncating those answers with super long decimal places like in that last array? What he's asking about is this right here. You know, when we're displaying an answer and it displays like this right here, effectively, the answer is 115. The reason why you get something like this is, I'm not going to say it's necessarily a problem, but it is a design choice for any binary computer system. It is not unique to Python. Any computing system that operates on binary will have this issue. And all computing systems are based on binary right now. You have this issue right here. And it's due to the fact that for the vast majority of floating point numbers, your computer cannot represent them with 100% accuracy. And that's why you end up with things like this, where it's, you know, it's 0.00000000001 away from what you thought it should be. But this is just an inherent limitation in binary computer systems. And actually, I'm going to post a video on the course page that explains in detail why it is like that. They can explain it better than I can. Yeah, but to answer your question, it is no. If your printed answer is this right here, that's perfectly fine. I understand what's going on, and I will accept that as an answer. If you want to do like the appropriate rounding and stuff like that, go right ahead. I'm not going to tell you not to, but you don't need to round or truncate these values. If you leave all the decimal places printed, I am fine with that, because I know what's going on and I know you did the right thing anyway. All right, no other questions? I will get this video posted up on the course page and the link sent out. Like I said, I will also post that video about the inaccuracy of floating point numbers. I think it's a really interesting video, so I encourage you to watch it if you're kind of wondering what's going on. Yeah, actually, as you can see, it's happening here and here as well. It's pretty interesting why that happens, in my opinion. But I'll get those posted up here in the next hour or so. All right, have a good rest of your day.